Hello there. This is Dr. Jeff Tarrant, and I'm the director of the NeuroMeditation Institute in Eugene, Oregon. And welcome. Thanks for joining us. And wanted to spend a little bit of time talking about some of the concerns that we see frequently with people who are trying to start or maintain or advance their meditation practice, and just the reality of how challenging that really is. So we feel like there's some ways that we can talk about and understand meditation that can be really helpful as far as uh, thinking about and really uh, creating a framework for thinking and talking about a meditation practice that can be really useful. In addition, we really wanted to introduce the idea of combining EEG biofeedback or neurofeedback with meditation as sort of a power tool, as a way to really increase the amount of information you can receive about your practice to help you develop quicker and more efficiently. So, this slide kind of sums up some of what I was just talking about, right? So what we're really interested in doing is creating a meditation for the 21st century. So we know from lots of research that meditation helps people feel better. It's beyond the scope of what we can get into today, but there's mountains of research showing that it can be helpful for everything ranging from anxiety and pain to decreasing blood pressure, increasing positive health outcomes, sleep, all kinds of things. We also know that meditation alters the structure and function of the brain. Um, Despite all this knowledge, people have a really hard time sticking with a practice. And some of the concerns that we hear frequently is that people don't know if they're doing it right. A lot of times we hear from people that they feel like they can't meditate because they've tried before and their mind is just running wild the whole time. And so they take that as some sort of confirmation that they can't meditate. Um, of course, the reality is that, well, that's just the way the mind works, and that's part of the process of meditation. Um, but this becomes one of those obstacles. People feeling like they don't have time to meditate, that they don't know where to start, associating meditation with Buddhism or Hinduism, and not feeling comfortable necessarily going to some sort of a Buddhist center or uh, a temple to learn these practices. So these are obstacles that get in the way. Some of the things that we have tried to provide to assist with this is first to really talk about meditation as a secular practice, that you don't have to believe anything. You don't have to make it a religious practice or a spiritual practice. It can really be a mental practice that applies to everybody. We want to make it efficient. We want to offer tools so that people can learn what it feels like to be in those states, to know that they're in the right state, and to get some information, some feedback about their process. That's super helpful, because otherwise, how do you know you're actually doing it right? I know people who have sat for years and years and years and thought they were meditating the way that it was designed, but when you really start to inquire about what they were doing, it's clear that they were really, daydreaming or relaxing, which is nice, but it's not necessarily the same thing as meditation. So it's important for us to define what we're talking about when we say meditation, uh, right from the outset. And we kind of did that a little bit on the last slide, talking about that it's not necessarily a religious or a spiritual practice. It certainly can be. And it's also important to recognize that the underlying, um, practice of meditation is really a mental training. It's a mental training that is designed to challenge the habitual ways that we pay attention, that we think, that we feel, that we perceive. And really a basic way of understanding and thinking about this is that the ways that we habitually pay attention and think and feel and perceive cause us a lot of trouble. So if you perceive a threat in the world when one's not there, that causes you distress. Or if you ruminate about things that might go wrong, the way that you're thinking or feeling, that causes distress. So really a lot of meditation is learning to recognize these habits and learning to work with them skillfully. So that's the definition that we're going to use. That's a very broad definition, but we like that because it encompasses kind of everything. Pretty much any meditation style is going to include that at a bare minimum. Now, the tricky part, of course, is that there's a lot of different kinds of meditations out there. We've got a list on this slide, and of course, this is not an exhaustive list, but it's a pretty good starting point of things that you might see in the research literature, things that have been studied. And even within each of these, there might be numerous different forms of meditation that you would find within each of these categories. So this creates a little bit of a problem about how we talk about meditation. We know that meditation is useful, but what types of meditation? There's a bazillion different variations out there. Are they all the same? Do they all have the same benefits? Do they do the same thing? And of course, the answer is no, they're not. They do different things in the brain. It depends on how you're paying attention and what your intention is. And so this is important for us to understand, because if you don't understand what it is that you're trying to achieve, you might be using the wrong kind of a practice. So we want to help people identify which style of practice is going to meet their needs best. So one way that we have started to make this a little more user-friendly is to categorize meditation into 4 different styles. Now, this isn't just us. We didn't just make this information up. It is based on a lot of research that's been done, that essentially there's 4 different styles of meditation. Now, these don't cover every possible thing that might happen in a meditation, but it covers most of it. So I'm just going to quickly go through these. So a focused style of practice is any kind of practice where you are holding your attention on a single target. So the breath or a mantra, a candle flame, an image of the Buddha, whatever. You're holding your attention on one thing. The mind wanders. You recognize that the mind wanders and you bring it back. So this is one of those practices that a lot of people, they think that is what meditation is. It's just one practice, but that's one flavor of meditation. So we're calling it focus. You'll also see it called focused attention. You'll see it called concentration practice. It's basically the same thing. And what we know is that any practice that asks you to use your attention and intention in that way is going to have a very similar impact on the brain. So we can kind of lump all those into one category. Now, mindfulness is our next category. And, this is an interesting one because the term mindfulness right now is being used to mean just about anything in our culture. So it can, people are using it to mean relaxation or as an umbrella term to encompass every kind of different style of meditation. We're using it in a very particular way. So it's kind of one flavor of meditation. And so the definition that we're using of mindfulness is that it's a non-judgmental awareness of the present moment. So these are any kind of practices where you are shifting into observer mode. You're noticing what's happening in the moment, noticing your thoughts, noticing your feelings, noticing your bodily sensations, and allowing them to be there just as they are without pushing anything away, without grasping for things you like. So it's very much this ability to accept things as they are. And you can see how that's a little bit of a different practice than focus. When we talk about, what is how are you using your attention and what is your intention? You're doing 2 different things. Consequently, it affects the brain differently. The third category we call open heart. And this is largely practices like loving kindness and compassion practices. But we also wanted to use a term that's a little broader to include things like gratitude practices or forgiveness, certain kinds of prayer would all fit in here. So really the heart of, no pun intended, the heart of these practices is activating a positive emotional state and then doing something with that. So either sending those feelings to yourself, sending them out to others, that kind of practice. And so it's really cultivating those feeling states. And again, you can see how this is different than the other practices. This one very intentionally involves cultivating feelings. The other ones, you might feel positive, you might feel joy or happiness or compassion, but that's not necessarily the intention of the practice. And then the fourth category we call quiet mind. In the research, it's sometimes called automatic self-transcending. And this, again, is kind of a stereotype of meditation, that you're kind of emptying your mind, that you're getting to a place where there's nothing happening. It's just, quiet. Now, that can happen. By the way, if you try to make this happen, it usually doesn't work. You have to allow it to unfold on its own, kind of a very gentle process of learning to allow the mind to kind of move into this space. And again, very different than the other four. So these in general are kind of the four categories that, that we explore and work with. Now, once you kind of understand those basic four categories, you can start to ask the question, well, which one would be a good practice for me? Which one should I use? And, this slide is really designed as a starting point to begin that conversation. It's not meant to be a definitive guide, right? That it's like, well, if you have, whatever, if you're dealing with resentment, that doesn't necessarily mean open heart is absolutely the thing you should be doing. But what we want to do here is help people to recognize that the way that you're using your brain with these practices can have a very direct influence on certain kinds of concerns or to help you achieve certain goals. So, for example, in the focus style, what are you learning to do? You're learning to hold your attention on one thing. When you get distracted, to get yourself back on track. So really what you're doing here is developing your frontal lobes. So if you think about that, any kind of concern that involves the frontal lobes, so ADHD, any kind of cognitive impairment, or other slow brainwave kind of activity concerns like you might see in depression, would benefit from focus practices. Let's look at mindfulness. So with mindfulness, what you are doing is you're learning to not attach to thoughts and feelings and bodily sensations, which is, of course, the exact opposite of what happens with stress and anxiety. You attach to certain thoughts, certain feelings, and you kind of do that over and over. That's part of what anxiety is. In fact, if you think about worry, what is worry? Worry is pretty much repeating the same thought over and over and over again. You can't let it go. So again, mindfulness is providing a counterbalance. So you can really think of these different practices as providing a counterbalance to specific concerns. So open heart's going to be a pretty obvious one. So certain kinds of mood issues, unresolved grief, empathy, gaining perspective, it's going to be helpful for all those things. Quiet mind can actually be helpful for just about anything, but there's some caveats there. So it can be really good for any kinds of concerns where your view of yourself is distorted. So if you don't see yourself accurately or you have a very negative view of yourself, being able to get into a space where you can shut that process down for a little while allows an opportunity for something new to happen, for you to start to create a new identity, a new way of seeing yourself. So that could be helpful for a lot of different things. Of course, this is a difficult practice for a lot of people. They have a really hard time getting. And if you already have kind of a slow brain pattern, you may not want to do this practice because you're just aggravating your baseline brainwave pattern, which is, so it's not being counterbalanced. So there's reasons why you may want to kind of choose one of these and not choose others. So we created a style inventory. You can see the website down there at the bottom of the page, www.neuromeditationinstitute.com/what's your style. And this survey is a way for you to go in and answer some questions. There's 33 questions, and it will give you a score for each of the 4 styles. So it's really looking at, well, what are your concerns? What is it that you're interested in doing? And then it will help you identify which style might be a good starting point. So it's another tool you might check out. Okay, now before we can get into talking about these 4 styles and how we might incorporate that into neurofeedback, we need to understand a little bit about brainwaves themselves, because that's what that's the language we're going to be using when we're talking about EEG neuromeditation. So combining neurofeedback with meditation. So I just have a few slides to make sure we're all kind of on the same page when we're talking about what brainwaves are. So the basic idea is that every cell in your body produces electricity. They're teeny tiny amounts of electricity, but every time a brain cell, we're interested in the brain, so we'll just focus on the brain. Every time a brain cell fires a signal, that produces an electrical impulse. So if here's one brain cell here, and it fires a signal down to the end of to the synapses where it releases chemicals, neurochemicals such as norepinephrine and dopamine and serotonin. That gets released here and then connects to the next cell that's nearby. And then that cell makes a decision, I'm going to fire a signal or not fire a signal. And then when it sends a signal, it's another electrical signal. Now, what happens is, because you've got, thousands upon thousands upon thousands of brain cells firing, thousands of times a second, that's a lot of electricity that's being generated moment to moment. And what happens is that through a process called volume conduction, that electricity moves through the brain in waves and patterns. So if you put an electrode on the surface of the head, you can actually measure that electrical pattern moving through the brain up to the surface. So that's what an EEG is. That's what an EEG does on an electroencephalogram. So you put electrodes on the surface and you can measure some of the electrical activity that's happening in the brain, and it can give you some information about the person's state of consciousness. So this is why the EEG is very interesting. Let's break this down a little bit more. Here's an image of a 19-channel EEG. These are actually my brain waves. And this is one of the EEG systems I use. It's called Brain Avatar by a company called Brainmaster. And so you can see the EEG for 19 different channels. So you put a little cap on your head and it's got 19 electrodes built into it. And so I can simultaneously measure 19 different areas of the brain at the same time. Now, this kind of an image right here is called a raw EEG or a clinical EEG because it hasn't really been processed. It's just measuring all of the activity, all of the electrical activity at each one of those locations and showing it to you in real time. Now, if you go to the hospital and they're interested in looking at your EEG because of concerns of a seizure or some sort of a brain injury or something like that, this type of clinical EEG or raw signal works great. So if you're a neurologist and you're looking at this, you can make some assumptions and some interpretations about what you're seeing. Now, if we're interested in looking at more subtle states of consciousness, meditative states, we need a little bit more detail, because for most of us, if you just look at all these squiggle lines, it doesn't mean a whole lot. So we do something that's called a quantitative EEG. So we take all this data, all these squiggle lines, and transform it into numbers so that we can kind of get more of a data-driven idea of what's happening and a way to compare different locations and different brainwaves. So let me show you how that works. So the basic idea is that you can measure an EEG using two different metrics. The first one is frequency, and it's how fast the wave is. It's how many repetitions there are of the electrical signal in 1 second. So if you measure the cycles, and a cycle is from peak to peak, let's pretend that this is 1 second. So there's 1 cycle, 2 cycles. So this would be 2 cycles per second, or 2 hertz. So it's measured the same way as any other electricity. So the electricity coming out of your wall socket in your room, if you're in the United States, is 60 hertz. If you're in Europe, it's 50 hertz. So it's 60 or 50 cycles per second. So here we have a 2 cycle per second cycle. It's called 2 hertz. So this is one thing that we're interested in, is how fast is the signal. The other metric we're interested in is called amplitude, and it's how big is the pattern. How big is this waveform? So it's a measure of power, and it's measured in microvolts. So we have to know how fast it is, how many repetitions there are, and how much power there is. So when we know that, now we can start to compare things. So we could measure somebody before meditation and during meditation, and we could look at different frequencies and the power to see how things have changed. So this is how it kind of works. So I use this, the analogy of white light going through a prism to understand how we can filter these signals. So if you go back for a second to this screen with the raw data, each one of these little squiggle lines actually contains a whole lot of different frequencies. It's not just one thing. There's a whole bunch of information contained in here, but you can't see it. So it's kind of like this beam of white light. So a beam of white light actually contains a lot of information. There's a lot of different frequencies contained in white light, but you don't see it until you run it through a prism. When you shine white light through a prism, out the other side comes a rainbow. And a rainbow are different color frequencies. So red is a different frequency than yellow, it's a different frequency than blue. But all of them are contained in that beam of white light. You just don't see it until it's filtered. So we have to do the same thing with brain waves. So we take the raw brain waves and we digitally filter it. So there's different ways to do that. But essentially what it does is looks at the different frequencies that are contained in that one brainwave signal. So the reality is that the brain contains a whole bunch of different frequencies. Slow stuff like 2 hertz, like we just kind of talked about, 2 cycles per second. And we actually don't know how fast it goes. We know, it goes beyond 100 hertz, but it goes much faster than that, I'm sure. So we have all these frequencies happening in the brain all the time, everywhere. So this becomes, this is a lot of data to sort of analyze. And so this is why what we tend to do is put them into clusters. And so this is kind of the information that most of us are familiar with when you think about brain waves or you hear about brain waves, are things like alpha waves or beta waves. And what those categories are clusters of frequencies. So you can see on this screen, delta is 1 to 3 hertz. So it's the slowest brainwave activity. And if you look at the bottom of this chart, here's an example of delta wave. Here's 1 second of time. you can see these big, slow, lopey waves. So it's one, maybe two or three cycles within 1 second of time. So that's delta. Theta is a little bit faster. So 4 to 7, usually you'll see it as 4 to 8 hertz. So here's an example of theta right here. So it's a little bit, it's faster than the delta. There's more repetitions, but it's still considered a slow brainwave. Here's alpha, a little bit faster. Alpha has a very distinct morphology, the way that the waves look. It's this very clean, pretty up and down pattern. And again, if I go back to this raw image, you can actually see some alpha here because of that nice, clean, up and down sinusoidal pattern. So we know that's alpha. You can also count how many repetitions there are in a second of time to figure out what the frequency is. Now, this doesn't mean alpha is the only thing in here, but it means it's kind of dominant. It's kind of taking over the signal right there. So there's other stuff in there. There's beta in there, and there's delta in there, but the alpha is dominant. Okay. So we have these different categories, right? So we've got slow stuff down at delta, theta, alpha's getting a little bit faster. And then we have a bunch of categories of beta. So sometimes you'll hear people talk about beta as anything above 12 hertz. Usually it's broken into little small categories, like you'll see things like beta 1, beta 2, beta 3, things like that. High beta, and then gamma. Gamma is kind of the new kid on the block. It's the fastest brain wave that we deal with. And it's an interesting one because of the states of consciousness that it's associated with. So these are the kind of charts that we normally see, right? These kind of simplified charts suggesting that, oh, delta is sleep. It's like, well, delta is not, the only thing that's happening in sleep. But at the same time, if you have a lot of delta, you're probably unconscious. Delta is a very slow brainwave. It's hard to be alert and focused when you've got a ton of slow brainwave activity. Theta, again, is slow. Now you see on this chart, they put meditation here. And I left it there because this is what tends to happen. People tend to associate meditation with a particular brainwave state. And that's not entirely accurate because it depends on what kind of meditation you're doing. Now, theta is associated with things like memory, intuition, the subconscious mind, creativity. That you'll often see a lot of theta in people who are creative. Alpha is more of a relaxed, neutral state. Now you see creativity there. I would argue that theta is a little bit more creative than alpha. But alpha tends to be our baseline. So if you close your eyes and you're just sitting there doing nothing, we tend to get a nice big boost of alpha. It's more of a quiet internal state. Beta is fast activity. So this kind of beta that we're talking about here is mostly something associated with an active brain state. So you're thinking, you're analyzing, you're actively doing something with your brain. And then gamma. Gamma is the fastest, but it's actually associated with kind of a little bit more like being in a flow state or being in the zone. So you have, it's like integrating high levels of information, but without trying too hard. You're not efforting like you are in beta. You just kind of understand something. It's like those aha moments. So it's kind of a higher level of understanding. So this is kind of a basic way of understanding what these different brainwave states do. And so you can start to get the idea that it's like, depending on how much of each one of these you have in different brain regions, that could be associated with different kinds of states of consciousness, whether it's sleeping or whether it's balancing your checkbook or whether it's a certain kind of meditation. It's how these all interact with each other in different brain regions that really makes the difference. So just to give you a really quick kind of overview, this is a way oversimplified kind of way of talking about this, but just so that you start to get the idea. So each of those 4 meditation styles that we talked about at the beginning have a different brainwave pattern that's associated with it. So focus is associated with more fast activity. So beta 2 or gamma, that fast brainwave stuff, because think about it, you are actively holding your attention on something. That requires your brain to be active. You can't just be kind of hanging out or spaced out and do a focus type meditation. It requires an active brain. So that's different than a lot of people think about. They think about meditation as being this totally quiet brainwave state, but that's not necessarily true. Now, mindfulness is more of a quiet state. So one of the patterns you see here is an increase of something called frontal midline theta. So theta is a slower brain wave. Remember, it's right above delta. And frontal midline means it's really occurring in the front midline area. There's a specific brain region there called the anterior cingulate, which is where that frontal midline theta generates from. And this type of brain wave is associated with some cognitive activity, but it's a very gentle cognitive activity. Remember, think of what you're doing with mindfulness. It's a soft attention. It's a gentle attention. It's an allowing attention. And so because of that, it's a slower brain wave. Now, open heart, we see that gamma again. There's research that's been done. Richie Davidson and his group at the University of Wisconsin have done a lot of work with these Tibetan monks during a compassion meditation. And what you see is you don't see slow activity, you see massive increases of gamma in specific brain regions because they are activating certain parts of their brain at a very high level. So areas involved in compassion, feeling emotions in the body, of attention, things like that are becoming activated because of the type of practice they're doing. And then quiet mind. So again, another slow brain wave. So alpha 1. So you can take the alpha brain waves and divide them into 2 categories, alpha 1 and alpha 2. And alpha 1 is the slower part of that. So that's the one you're going to see increase during a quiet mind practice. Alpha 2 is a little faster. It's almost kind of like beta. So we don't really want to see that as much. We want to see this more resting state brainwave that you'll see with quiet mind. So 2 of these, so focus and open heart, both increase fast brain waves, and 2 of them, mindfulness and quiet mind, increase slow brain waves. So again, you can start to see that depending on what your goal is, what you're trying to accomplish, you may want to slow your brain down, you may want to speed your brain up. And so again, choosing which practice is going to be the best fit for you, this is again a simple way to start to think about this. And it also starts to make the connection to how we're going to measure these things with EEG neurofeedback and sort of connect that to our practice. So in order to kind of make this sort of understandable and sort of simple in this context, I thought we would just focus on a focus practice. So I'm going to explain kind of how this works in the brain in a little bit more detail, and then I'm going to show you a demonstration. So I'll pull up my neurofeedback software and kind of do a playback session so that you can kind of see how this works. But first you need to kind of understand what's happening in a focus practice. So again, just as a reminder, a focus practice is going to be any kind of a practice where you're choosing an object for your attention. So the breath is a common one, right? Or a mantra, where you're holding your attention on one thing. So you're just watching the breath, you're watching the breath, you're watching the breath. When the mind wanders, you recognize that you're off track and you bring the attention back. That's it. That's the practice. Sounds very simple. And for any of you who have ever tried this, it's not simple. It's actually really challenging because the mind loves to go find something more interesting to do. It gets bored. It gets bored easy. And so it's going to go try to find something more interesting than watching your breath. And so your job is just to bring it back and bring it back and bring it back. Now, what's going on in the brain during this process? Well, this was a really excellent study that was done a few years ago. And you can see from the name of it, mind wandering and attention during focused attention. So they measured this, right? A fine-grained temporal analysis of fluctuating cognitive states. Now, what they hypothesized, this is their hypothesis from this study, is that basically you're using two different networks in the brain. So you're using your attention networks when you're focusing, right? So let's start over here. So you're sustaining your focus, you're paying attention to something, but then your mind wanders. You lose track of what it is. You start thinking about your favorite Netflix show, or you start worrying about the pandemic or whatever. So your mind wanders. So at that point, you're not in your attention network anymore. You're in something called the default mode network. And we'll talk about that more in just a moment. But your default mode network is kind of you thinking about yourself or thinking about something in relation to yourself. So when you mind wander, that's usually what you're doing. You're thinking about something else connected to you or your identity or your family or whatever. So you're mind wandering, the default mode network gets active. Then you become aware that your mind wandered, and then you're back in your attention network. Shift your attention back and you sustain your focus. So this was their hypothesis, is that basically you would see these two different networks kind of taking turns. Now, here's a little bit more of a complicated chart showing what they actually found. So it was a little bit more complicated than that. Their basic idea was right, but it was a little more complicated. So again, let's start down here at the bottom, sustaining focus. So there's that frontal lobe, the dorsolateral prefrontal cortex. So this is part of the attention network, the executive network. So when you're holding your attention on something, your frontal lobes are activated. Then your mind wanders. Look at all the brain regions that are active here, because you're thinking about yourself and you're connecting, whatever it is you're thinking about to all kinds of different, memories and things about the future and whatever. So this is, a lot of these regions are part of the default mode network. So there it is getting activated. And then you become aware that you're distracted. So this is a different network that they didn't really hypothesize, the salience network. So this is your brain kind of saying, well, what's the important thing to pay attention to, right? And then you shift it back, and there you see it starting to go back to the frontal lobes again. So this is the sort of basic process. Now for us, in thinking about this practice in terms of a very practical application, we actually don't need all of this. That's a lot of things to try to monitor with an EEG and pay attention. That's a lot to have to track. So really, what we're interested in are these two. What's happening when I'm focused and what's happening when my mind wanders. These two, while they're important, are very brief. Think about it. If you're doing a meditation, you're focused on your breath, your mind wanders. Now, when you become aware that your mind wanders, how long does that process last before you shift back? Like, these two things are usually very brief. Most of your time is spent here. So that's what we're interested in. Focused versus not focused. So one part of the brain that is really important for focusing is the anterior cingulate. I mentioned this earlier. It's right up in the front. So you can see it here. Here's the frontal lobe. So here's the forehead. And there's that anterior cingulate right behind the forehead. And when you are holding your attention on a single task, when you're selectively paying attention, or when you're inhibiting your response to something else, so I'm not paying attention to that, I'm just paying attention to this, it involves activating your anterior cingulate. So we know we want that to be engaged. We want that to be active. And if you remember from one of the earlier slides, when we were talking about brainwaves, we were talking about beta 2 or gamma. Those are fast brainwaves. So we expect to see an increase of fast brainwave activity somewhere up in this frontal lobe. So maybe right exactly, on that anterior cingulate. So that's one piece that's important. The other piece that we need to pay attention to is that default mode network. So remember, that's all of those brain regions that we saw that have to do with mind wandering, that have to do with thinking about yourself or something about yourself. So we don't want this to be active. We want this to be quiet. So we want this one to be, the anterior cingulate to be active. We're focused on something, but we want the default mode network to be quiet because we don't want to be thinking about ourselves. Now, the hub of the default mode network is at the back of the head, right here, called the posterior cingulate. So we're dealing with the anterior cingulate when we're focused and the posterior cingulate when we're distracted and we're mind wandering. So those become the two things that we're really going to be interested in from a neurofeedback perspective. And here I've got it kind of laid out. So again, we want to activate the anterior cingulate and we want to quiet down the posterior cingulate. And we want to connect that to our meditation. So I'm going to show you kind of what that looks like on a screen. These are just some different images of what it looks like when somebody's hooked up. So here's me, and you can see, this is, I'm looking at that posterior cingulate. You can kind of see it highlighted on the screen. So I'm measuring that activity at the moment. Now this is a full cap, so you can see that's the one with 19 electrodes. Here's a different version on the bottom. It's 19 electrodes, but it's more of, kind of a rubber connector. This was at a workshop we were doing in Germany. And then here's a picture showing somebody hooked up with just 2 channels. So you don't have to use the whole 19 electrode thing. You can do a simplified version with just 2 electrodes without putting the whole cap on. Okay, so let me show you kind of what this looks like with a playback. So I'm going to change my screen to my Brain Master software. And I'm just going to play back a file. So this is somebody's actual EEG data. It's just not live. We're just playing it back. And so you should be seeing, kind of the squiggle lines going across the screen. So this is that raw EEG, right? You remember, just like the screen that we showed earlier in this presentation. So there's a lot of data going on. Look, there's some of that alpha that we talked about. Remember the alpha? Got that nice sinusoidal pattern. See it right there. When the alpha goes away, it's usually faster. So you can kind of see that right here. A little faster brainwave pattern. So now we can monitor it this way, but then we can kind of group it, right? So this is actually the screen that's more interesting, because what I've done on this screen is isolate the gamma activity in the anterior cingulate. So that's the one up front. Gamma is the fast brainwave. I want that gamma to increase to indicate that they're paying attention and they're focused. So in this case, you can see there's a solid yellow line. That's the threshold. And I'm going to want their gamma to be above that threshold. That tells me that they're focused and alert. When that gamma drops below the threshold, that's going to be an indicator to me that they're kind of spacing out, or they're getting sleepy or something like that. So this part of the equation is telling me, are you engaged? Are you focused? Are you alert? But I don't actually know what they're paying attention to. So even when this gamma gets high, and I know they're alert, I don't really know what they're paying attention to. Because you could be alert and thinking about yourself. You could be alert and thinking about money, or thinking about, whatever. That's not meditation. So this one only tells me part of the equation. Are you engaged with something? This one, the second part, you see it says PCC. That's the posterior cingulate. I want this one to be quiet. Because remember, this one is giving me an indication of what you're paying attention to. So if that beta activity is high, then that means the person is probably thinking about themselves. So if it's above the orange line, they're mind wandering. Okay, that just went off the chart. That's called an artifact. That means the person moved or blinked. There was some sort of muscle activity that caused that to jump off the chart. That's not real brain waves. So here it comes back, settling back down, real brain waves. So you see the beta is kind of hanging out a little bit above the line. Now it's going below the line. This is telling me what they're paying attention to. Not specifically, I don't know what they're thinking. But if it's above the line, they're going to be thinking about themselves, mind wandering. If it's below the line, then they're going to be have more of a quiet internal state and only focused on one thing. So what I want is this above the line. Look, it moved up. And this one below the line. Ooh, that's a perfect, right there that we just saw. That was a perfect indicator of they were in the right zone of being active, but keeping the mind wandering to a minimum. Now, how do we feed this information back to somebody? Because if somebody's watching this while they're meditating, it's going to be hard to meditate. This is a lot of distracting information. So the person meditating isn't actually watching this. What they're doing is listening to music, and the music is connected to this. So let me turn that on. I had it muted. Now the way the music works, I've got some nice meditation music playing in the background. And what's going to happen is that when this one is above the line and this one is below the line, that's what we want. When they're meditating, meditation music gets a little bit louder, and that's the signal that you're doing it right, that you're on track. When either one of these is in the wrong spot, the music is quieter. That's the feedback telling the person, yeah, you're not quite there. You're distracted, something's going on. You're spacing out or you're not right. So I'm going to turn the volume up just a little bit so you can kind of hear this and kind of watch the process for a few moments. So listen to how the watch. So the volume's quiet right now because they're not fully engaged, because this one is low. They have to get this one up in order for the volume to go up. Now, I can make it easier, or I can make it harder. So in this case, for demonstration purposes, I'm going to make this one a little bit easier. So you can see I'm going to move this yellow line down a little bit. Yeah, I'm going to mute that music so that I can talk to you again. So, as you might, kind of assume, and you'd be right in assuming this, there's a lot of variation depending on the individual. Look how low this just went. Look how low this beta is right now. So during this moment, their mind is very quiet, right? And at the same time, this one is still up. So that's a really excellent little moment. Now look how much it just raised up. Now they're engaged in some sort of thought process. So part of what happens with this is you need to sort of understand the individual and understand how they work. So somebody just asked a question, EEG is covered by medical insurance. It depends. It's a good question. It depends on the insurance, and it depends on how the provider is billing it. So if it's a neurofeedback session, usually I bill that as psychophysiological therapy. So there's a billing code 90876. that most insurance companies will pay for. And so then the issue is, what are you using it for? So if I'm using this for somebody with, let's say, anxiety, then that's a legitimate thing to bill for. So treatment for anxiety, I'm a psychologist, I can do that. So so that's kind of how that works as far as billing insurance. Some people will do this in other ways to make it cost effective. And actually, I'll talk about that in just a second. Anyway, there's an art to this of really sort of understanding, as the clinician or as the therapist or whatever, of really understanding what these patterns mean and how to connect it to the other person's internal state. Because the goal is to help the user get really good at understanding those subtle internal states because of the changes in feedback. It's actually pretty amazing because you'll start to become aware of very, very tiny changes in your internal state because you're getting feedback that's saying, hey, something just changed. And then you become aware, oh, what just happened? What was that? And so you learn to kind of navigate your internal state much more efficiently than I think occurs without this type of feedback. So let me go back to the other screen. We have a couple more slides that I want to share. This is something that's still pretty young in terms of research. I mean, we've been doing this at the NeuroMeditation Institute for a while, and this has been my full-time job for about 5 years. But the research is really still pretty young. But there are a few studies that have been published. So here's one, and it's with a focused practice. So it's kind of what we were just talking about. And they were actually using an fMRI feedback system as opposed to EEG. So they have somebody in an MRI device measuring brain activation. And guess what they were measuring? They were measuring the posterior cingulate, the hub of the default mode network. And they were showing the people that were in the MRI machine whether the posterior cingulate was active or not. So looking at blood flow. Is there an increase or a decrease of blood flow? And what they found was that when they gave this information to non-meditators and meditators, both groups reported that when the posterior cingulate was active, they were mind wandering, not surprising. And when it was deactivated, that's when they were engaged in meditation. Now you can see on this, the blue lines are when it was deactive. So kind of, you can think of the middle part here as baseline. So when the blue line drops down, that's when the PCC became less active. The red line was when it became more active. So you can see the non-meditators weren't quite as good at this as the meditators. The meditators figured it out pretty quick. And look how much the process changed by them having that feedback and being able to sort of connect it to what's happening internally. Now, the reality is actually the non-meditators actually did pretty good too. You see that second half, there's actually a lot more deactivation than activation. But it's not going to be as dramatic as experienced meditators for obvious reasons. It takes some practice to get good at this. Here's another study where what they did was it was a little bit different because they were measuring the posterior cingulate, again, that hub of the default mode network, in real time, but then they would interrupt the meditators when the posterior cingulate was active or when it was deactivated and ask them what was going on. And again, it's just more evidence that when the PCC is active, people tend to be distracted. They tend to be controlling what's happening internally. Whereas when it's deactivated, they reported an undistracted awareness, effortless doing. So being able to focus without pushing, without trying, without being distracted by a bunch of other stuff. So this is why even just that one spot, being able to measure that in real time is so powerful. And they did another study, source space EEG neurofeedback. So that's what we were just looking at, EEG neurofeedback, linking subjective experience with brain activity during effortless awareness. Now, what they found in this study, it was interesting that both novice and experienced meditators demonstrated decreased activity in the posterior cingulate during this effortless awareness meditation. And they were both able to control the signal by, when you provided them feedback, they were able to learn how to control it. So even though we only have a few studies out at this point, it's all very promising and positive. Now, from a clinician standpoint, I've been doing this with people for a long time. I know it works, but of course, it's good to have research to kind of back that up. One of the things that we've been doing more recently, because of COVID, but also just to make it more accessible, is remote training. So technology has really allowed us to do something pretty cool. It's great to come into the office, to have people in the office and hook them up and be able to do this in person. And that's not always possible, and it's not possible right now. So what we started doing is offering sort of packages where we'll do an individual assessment for somebody to help them determine which meditation style might be best, because there's different EEG protocols based on which meditation you're doing. And then we can either rent them a simplified EEG system that we'll send to them and they can hook up at home, or they can buy a simplified system. So not quite as complex as that 19-channel thing, more like the 2-channel system. And then we can actually use Zoom or some other platform to take control of the other person's computer. So I just did this the other day with somebody in Massachusetts, and I'm in Oregon. So I can take control of their computer and run them through a session and control the thresholds while they're doing their meditation, 10 states away. So all they have to know how to do is how to put the electrodes on their head, which is pretty simple. And then we can kind of, track that progress, through some questionnaires and by analyzing the EEG data. So anyway, there's some fun options that are available now that didn't used to be available for how to engage with this. I don't have a slide on this, but we also have a process to teach people how to do this. We teach workshops, both remotely and live. Anyway, I know I'm coming right up to the top of the hour. It's amazing how fast time goes. If anybody has any other questions, I'd be happy to take them now, or you can also, send me an email outside of this, and happy to communicate with you on the side as well. Just giving a second here to see if anybody has anything. Got one thing. You're welcome. So one person just sent me a thank you. Hey, you're very welcome. Glad you guys can make it. So I'll go ahead and wrap this up. I'm going to make this available on our YouTube channel so that, if you wanted to see it again, or if somebody else wants to watch it, it'll be available. If you have any questions, just shoot me an email. You can find me at jeff@neuromeditationinstitute.com. Happy to talk with you about it. Thanks for your interest, and stay safe out there. All right, we'll see you guys later.